Assalamualaikum. So we are here in this video to present you our project, the face mask detection system. First, let me introduce myself first. So my name is Noraina Sofia BITI1113. I will present you the introduction and the problem statement of this project.
Hi, my name is Noriana Akira BITI1113. I will present about objectives and anticipate impact.
Hi, I'm Danisha Varshini Mohindan and I will explain about the system design.
Hi, my name is Nur Akila Beduzedi. I will present system demo and feature improvement.
Okay, first let me introduce what our system is. At its core, it's an AI expert system. It works by using a standard webcam to provide a real-time automated monitoring of surgical mask compliance. So the main purpose of this system is to safeguard sterile environment in hospital, acting as an automated checkpoint at areas like entrance to and operating rooms. These ensure safety protocols are followed before anyone enters critical zone. As you can see from the screenshot, it provides instant visual feedback. Like as you can see that they said without mask and with mask. So next, we're going to look at the problem statement. Now, let's discuss the specific problem our system was designed to solve. The main challenge is that manual supervision of mask wearing is often inconsistent, as we know. Relying on people to check everyone, especially at busy entry point to sterile area, can lead to human error. The consequence of this very serious. It creates a vulnerability in hospital infection control protocol. A single mistake can increase the risk of contamination, which can lead to dangerous surgical site infection for patient. Therefore, our goal with this project was to create reliable automated solution to close this critical safety gap and to ensure ensure compliance in consistently monitored. Now, to explain the specific objective of our project, the impact we hope to achieve, I will pass the presentation to Atira.
Okay, thank you, Aina. So next, this is our objectives. The first one, to design and implement AI-based a system intended to detect the presence or absence of a surgical face mask on medical personnel in real time. The second objective is to classify mask uses to aim distinguish between correctly worn fully covering nose and mouth and incorrectly worn or absent states. Third objective is to integrate capability, identify the specific medical personnel whose mask compliance is being monitored, authorization, facial recognition data. And last, our objective is to develop a mechanism immediate on-screen feedback upon detecting mask non-compliance for a specific individual, thereby supporting prompt and correction. So next, please anticipate impact. So the first anticipate impact is enhance patient safety. First and the most important risk is patient safety. In a hospital, the biggest risk in satellite area like an operating room in infection. Our system acts as constant digital guardian by making sure every mask is worn correctly is directly cut down the risk of germs contaminating the environment. This means a lower chance of patients getting dangerous and constantly surgical site infection, helping them recover faster and safer. The point two is improve staff compliance and accountability. Our system to improve staff compliance and accountability right now, making sure everyone wear their mask correctly rely on senior staff, reminding their colleagues. This can be inconsistent and sometimes awkward. Our system automate this is provide instant objective feedback on a screen. It's not personal, it's just data. This removes the human friction and help build a stronger culture where safety is shared, automating responsibility for the entire system. For three is increase operation efficiency. It's a good operation efficiency. Monitoring mask is a simple but vital task. By automating it, we are free up highly skilled medical professionals like just nurse or surgeon from having to do it themselves. This allows them to focus 100% of their attention on what truly matters: complex patient care, critical decision making, and performing produce without distraction. Number four, for data-driven insight for improvement. The system gives us data-driven insight. It doesn't just see a problem, it's a law. It can record when a compliance issue happens most often. Hospital administration can then use this data to see a real pattern. For example, they might be a fine compliance a drop near the end of the long shift. With knowledge, they can make a smart targeted change, like editing and reminding in specific area, adjusting training instead of just guessing what the problem. But last is reduction in human error. Finally, all of this lead to a significant reduction in human error. People get tired, busy, and distracted. A human supervision cannot watch everyone all the time. Our AI system can. It's reliable and unbiased safety net that work 24/7, catching the small mistakes that are avoidable part of any human-run process. It ensures the standard safety remain high always. So next, I will give to next presenter.
All right, thank you, Atira. Now, I'm Danisha going to present about the system design part. So, first one is data set contains images labeled as wearing mask and not wearing mask. We used about 6,043 images belonging to the two classes for the training, and for validation we used about 1,510 images. So for the detection of the face mask usage, the facial features and accessories that the system will detect are nose visibility, mouth coverage, mask coverage, and mask strap placement. And for the third one is inference engine we used for our system is forward chaining method, where rule A will use the rule 1, where it will detect as wearing mask, and B and C will be the rule 3 and rule 3, where it will detect not wearing mask. Rule legend A is nose invisible, mouth covered fully, mask worn properly, mask straps around ears. So this will be detected as wearing mask. B, nose visible, mouth covered, mask not worn properly, mask straps around ears. It is detected as not wearing mask. And the last one is nose visible, mouth covered, mouth not covered, mask is absent, mask straps invisible around ears. So it will also detect as not wearing mask. So I'll pass to Akila for the next part.
Okay, next I will explain about system demo. So I would like to show a video demo of our system. So when you see the video, the system use the webcam to scan the face. If the person is not wearing mask, it will give a warning and show the person name. If the person wear a mask, it will give a code message. This show that the face recognition and mask detection work well. So here is the video. Next is the future improvement. In the future, this project can be improved by training the model with a larger and more diverse data set. So that means the system can work well with more people in different places and lighting. Okay. And this will help the system work better in different lighting and with more people. And we also plan to add an audio alert feature to give a warning sound when someone is not wearing a mask. That means a sound or voice will play to warn the person if no mask is detected. Another improvement is to save the detection data like name, date, time, and image capture. That means a face capture. That means when someone is not wearing mask, their name, date, and face will be captured and will be saved in Excel. This is helpful for checking who are not always wearing masks. Okay. And lastly, we will try to reduce lag so the system run faster and smoother. When you see the demo, we have a problem that about the performance. We have a problem. The system might be laggy. So on feature improvement, we try to improve speed so the webcam and system run more smoothly. Okay, that's all from us. Thank you.
Thank you.